An undefined format is used for partition datasets that hold executable programs. This corresponds to the type of output produced when an executable program is produced. What the undefined format means is simply that there is no particular record length that could be considered typical. As a result, the record length is always indicated as 0, while the block size is used to determine what the size of the largest block is that can be written into the dataset. A point to remember is that many of the blocks written may be significantly smaller, but because there is no record length, then records cannot be logically grouped together as in the other formats. This particular definition should not be a cause of concern, since it is only applicable to libraries for executable programs, referred to as load libraries. Let's examine how this comes about. A source program or module is basically like a text file. It is something that we can read. In this example, the file in question is a listing of an assembler language program in ZOS. An assembler language program is written using mnemonics to produce machine language. So this example was chosen to illustrate how machine language is generated and is used to produce the final executable program. The translation process reads the source program and produces what is called an object module. This is where the source code is translated into specific records that contain the generated machine language. While other information will also be included, it isn't relevant for our example. The two highlighted boxes on this slide show the actual machine language for a particular instruction, and we can see that it is a hexadecimal 182F in the listing, and we can see the corresponding data in the object module that was produced. This slide is simply a more detailed look at that object module and the records that were produced during the translation. Again, the highlighted box shows the particular machine instruction we had just looked at. The object module is then input into another program which will produce the final executable program. Taking all of the information contained in the object module, the executable program or load module is written to a library with all the required control information. Again, the highlighted box allows us to keep track of the same machine instruction from the previous slides. What is notable here is the various sizes of the records that are produced when the load module is created. Notice that there is no specific length and that there can be a considerable amount of variability. More importantly, no two load modules will likely contain the same information, so the lengths may be considerably different between different programs. It is for this reason that the load library uses a record format of U for undefined. This means that not only can the records not be blocked, but that they are too nonspecific to have a particular length definition, so we use a record length of 0. The block size will then be used to simply indicate the largest physical block that should be written, but it really tells us nothing about the average size of the records that will be written. In this screen capture, we can see the definitions that are associated with this particular load library, and you can see the characteristics we've just described. The record length is 0, the block size is 6144, and the record format is U, or undefined. At this point, we shouldn't concern ourselves about the particular choice of a block size, because the rationale itself is a bit confusing and arbitrary. In general, if you need to choose a block size, it is easiest to model it after an existing library. Now, in this particular example, we've gone back to our utility screen, and in this case now, we are interested in looking at a load library. So the dataset name level now is gatom2.link, and we use the asterisk as a masking character so that in the event that we have a dataset name that has additional characters after it, we can go ahead and we can find those as well. Our initial view still contains the attributes so that we can see what attributes are associated with that dataset. So when I hit the Enter key, I have one dataset come up. You can see this is gatom2.linklib. Again, if we look under our dataset organization, we see this is a partitioned organization, but notice that the record format in this case is a U for undefined, logical record length is 0, and the block size is 6144. Now, load libraries cannot be edited, although they can be browsed. So what we can do in this case here is when we type in a B next to this particular dataset name, we can browse the contents of this particular dataset. And in this case, what we have then is we have a bunch of executable modules. Now, as we said, we cannot edit these, so when we take a look at any of them, what we're going to see is we're going to see the executable version of this particular program. Now, most of this, of course, is unreadable in any form like this. So what we can do is we can turn on the hexadecimal display so that we can see more of the details about the information that is contained. And as you can see, just as we said before with undefined formats, all of our lengths here are very different with respect to the information that's been written out. And so this is what an executable load module looks like when we have it translated and it's ready for execution. Let's now examine how members are updated and controlled within a PDS. In this example, we see member A is highlighted, and we will consider that we are editing it or updating it in some fashion. When we save it, the following events occur. The existing space for the member is not reused. Instead, the member is written into an existing available space, and finally the directory is updated to reflect the new location. The end result is that we now have some dead space in the library. As this kind of activity continues, we will eventually attempt to update a member and find ourselves having run out of space. When this occurs, the library must be compressed. This is comparable to a defrag, which is simply a mechanism to reclaim the dead space in the file, although, depending on the size of the file, it can go very, very quickly.